So we're going to do number one here. The baseball is hit nearly straight up in the air with a speed of 37 meters per second. How high does it go? How long is it in the air? So right away, first thing we definitely know about that baseball is as soon as it's hit, it's in free fall. So the baseball is in free fall. And if something's in free fall, what do we know about it? We know its acceleration. Which direction does that acceleration have to be in? Down. Well, negative, careful, negative, remember we can define any direction. So you're right if we define up as positive. So the acceleration is down. And does it have a specific value? 9.80 meters per second squared. So as soon as we see something in free fall, we know that it's accelerating downwards, and it's accelerating at 9.80 meters per second squared. Let's see. Something else we know about the baseball. We know it goes up and turns around. What do you have to do to turn around? You got to stop. So at the top, the velocity is 0. So it goes all the way up to the top, it stops, and then it turns around and comes back down. There is one assumption we have to make. We have to assume in this that whatever height it's hit at, it comes back down to that exact height. If we don't assume that, then we don't know how long it's going to take. So that's, I'm going to put that in my y because it's an assumption I'm making. Assume lands same place it started. So assuming that it goes up, stops, turn around, and comes back down. Anything in the Y that people have questions about, or yes? Well, no, I asked myself, what do I definitely know about this situation? And because the first thing that popped in my head was, oh, it's in free fall, so I know it's acceleration. And then I was thinking about the problem, and I said, okay, when it gets as high as it can go, that's when it turns around. And so the thing that flashes in my mind when I think about something turning around is that it has to stop to be able to do that. And then, so I said, okay, so that's how I put those two. And then the third one, I know that if I don't know where it lands, I don't know how long it's going to take. Or if I knew how long it took, I could tell you where it was landing. So that's where, probably the toughest one is that third one that you wouldn't think about right away. That's the one that comes with having judgment problems. So, all right. Any other questions on that why before we jump into the how? Say again, sorry? Yeah. Oh, yeah. And you know they're also in the documents folder. You can print them out from there, but yeah, I don't mind if you do it on your own paper. I think 2/3 of the people in here did. If you have. They're also right up here in this orange folder. If you'd like some of the copies I made, I'll be glad to make more. So. All right, so on to the how here. I'm going to do myself a little sketch. I know it goes up, it comes back down to the ground. Which direction do you guys want to call positive? Up, okay. We'll call that positive. Okay, with this the ground being at a height of 0 meters? Okay. And let's call all the way up top here a height of h, or height h. And let's see, we know the ball starts down here, and it's going up at 37 meters per second. He said when it gets up here, it's going to stop and turn around. So that means it's going at 0 meters per second up top there. And the whole time it's accelerating down at 9.80 meters per second squared. I'm just trying, for me, I'm a very visual person, so organizing these ideas visually helps me kind of grasp what's going on. It starts here. Yes? That I know because it's in free fall. And every object in free fall is accelerating down at 9.80 meters per second squared. Okay. All right. That's kind of our, as soon as I see something in free fall, jump right on that, because that's your key to getting it, is that they're all going to be in that. Kind of like the bungee jump guy. When he first, before the bungee cords, he was just in free fall. If he didn't have the bungee cords, that's why he'd splat at the bottom. When the bungee cord started stretching, he wasn't in free fall anymore. So, speed is how your distance is changing with respect to time. If we're talking about velocity, it's the direction you're moving in and how fast you're going. The speed is not always velocity. Speed and velocity are only the same number if you're moving in a straight line and you never change direction. What was your question? Because it says he has a speed, it's hit up with a speed of 37. Well, at the top. So it starts up at 37 meters per second, but it's accelerating at this, right? So every second that it moves up, it's losing, or it's not losing, that's not a good way to put it. Its velocity is changing by 10 downwards. Yes. Yes. So, just off the top of your head, about how long is it going to take to get to the top of this? If it starts up at about 40 and loses about 10 every second, about 4 seconds. It starts up at 40, and this tells us that it loses or it changes by 10 downwards every second. So after 1 second, you're going to be going 30, after 2, 20, after 3, 10, and after about 4 seconds, 0. Yes? No? How long do you, so it's going to take about 4 seconds to get up there. How long do you think it'll take to get down? About the same, because it will gain, it's gaining the speed that it lost at the same rate, so it's going to take just about as long to get down. Yes? No? No, it's going to take the exact same time. Exact same, because on the way up, it's changing still downwards. It's losing speed. On the way down, it's gaining speed, but at the same rate. Because no matter if you're going up or down, your speed is changing at this exact same rate, the acceleration. All right? All right? So, if it takes about 4 seconds to go up, it'll take about 4 seconds to go down. That's one of those things you may not have realized before. But the reason why is it's changing at the same rate on the way up as on the way down. So if it was going 37 meters per second upwards at the bottom, how fast is it going when it gets to the other end? 37, which direction? Yeah. Now, if you didn't realize these things, that's fine. There's ways these are extra facts that you don't need to solve it, but they make solving it or understanding it a lot easier. And the key is that everything in free fall is accelerating, is changing its speed downwards at 9.80 meters per second squared. The whole trip. That's why we did that interactive where I threw the ball up and it came down. So you could see proof that the acceleration was constant throughout that whole motion, the up and the down motion. All right? So now let's actually get to solving it. Now, hopefully we understand a little more what's going on. They want us to, how high does it go? So we know it starts at 37, it ends up stopping right at the top, 0 meters per second, once it's gone from 0 to a height of h. And the whole time it's accelerating down. So this is where I look at my equations and I say, is there one of them that says your velocity changes due to acceleration and how far you moved? And that's this one. This one says your velocity changes because you're accelerating for a certain amount of time. See there. Here it says the same thing, but because you accelerate for a certain distance. All right? Does everyone see that? Yes? This says I end up going this fast because I was going this fast and I accelerated for a certain distance here. That's what that equation, that's how I translate it. Yes? No? Okay. They will become more important next chapter, so if you leave off the arrows, that is fine. All that's indicating is that those are vectors. And we will spend a lot more time on the difference between vectors and scalars in our next topics. All right, so this is part A. Yes, sir. Well, okay. I was looking at this and saying I want to know how far it traveled to go from 37 meters per second to 0 meters per second while it was accelerating. So what I did is I looked at the equation and said, do I have an equation that talks about going from one velocity to another because I accelerated and I moved a certain distance? And that's how I picked that one. They said, how much time does it take to go from the bottom to the top? Then I'd look more over here and say, well, I know my velocity is changing because I accelerated and I took a certain amount of time to do that. If it talks a lot about, you end up here because you started here, that's where I more look at this top one. So, but there may be cases where you have to figure out how long something took and then figure out where you are. Like if it said, okay, after 15 seconds, or there's ones in here that have that in there where you need to figure out a time and then you figure out where you are. I did one in A block today. I think it was number 8 where we had to do it that way. You guys remember that video's up there from A block, right? So if you're looking like whatever ones they did today. Good question. So, luckily, I think I know enough to just straight use this equation, not use it to find something else, and then find what I want. But I think I know enough information. I know at the top it's going to be going 0 meters per second. I know at the bottom where I started the initial, it was going positive 37 meters per second. Now the final's where you end up. And I'm interested in how far it had to travel to go from the bottom to the top in this situation. Because at its highest point, it's going to stop. It's not going to go up anymore. And to turn around. Think about when the interactive we did where I threw the ball up. We had that parabolic shape. At the very top, it stopped and it had that slope of 0. And that's where our velocity graph crossed the axis. That's how I could break this. Remember, this doesn't say for the final. at the end of the world, and this is the beginning of the world. I could look at the first meter and figure out stuff. I can break this up however I want. And for right now, I'm interested in from the bottom till it gets to the top. Plus 2, and then my acceleration I know is downwards, so that's negative 9.80 meters per second squared. And my delta D, let me move this over. Move it over so I can. My delta D, remember that's change in displacement, change in where I am. So I end up at H, and I started at a height of 0. Oh, cool, I only have one variable, right? Remember, delta means change, and D means position. So I can either look at this and say, well, I went this far, which I could call H. Or if I want to be more mathematically technical about it, it's where I end up minus where I started. And final minus initial, that's actually on our equation sheet. So I end up at H, right, at the top. And I start at 0. So it's H minus 0. Or just H, because H minus 0 is H. Can you guys do the math there, you think? Yeah. Yeah. You guys think you can do the math? Okay, good. Because it should come out to 69.8 meters. And then part B, how long is it in the air? All right. Are we good on this? Can we go on to part B? Yeah. Because H is the position it's at when it turns around. And so if it doesn't move any distance, if it doesn't go from 0 to someplace, then it's not going to change at all. Because here at 0, it was moving up at 37. We deduce that when it gets back to 0, it's going to be moving down at 37. So H is not going to be 0 because it's the height it goes to get rid of that 37 meters per second. Because it's got to turn around at the top. All right? So now we want to know how long does it take to go from being hit till it comes back to the ground. We can look at it 2 ways. We already said it's going to take the same amount of time to go up as it is to come down, right? So we can figure out the time to go up and then multiply it by 2, right? Yes? Or we can say, no, let's look at the whole time, because we know it goes up at 37, and when it gets back here, it's going down at 37. So we could look at the amount of time to change from positive 37 to negative 37. Which way do you guys want to approach? You want to do it, figure out the time just to go from the bottom to the top and then double it, or figure out the time to go from 37 meters per second up to 37 meters per second down? The first one? Okay. Okay. So we're going to figure out the time it takes to go from the bottom from where it's hit to the very top, and then because we know it takes the same amount of time to come back down, we're going to double that amount of time. And that will give us our answer. So I know that it starts up at 37 meters per second, it's accelerating the whole time, and it ends up stopping. The equation that I'm going to use is this one here, because that talks about my velocity changing. I end up going this fast because I was going this fast and I accelerated for a certain amount of time. And we know it's accelerating the whole way up. So I end up at the top. How fast am I? What's my velocity at the top? 0. 0 meters per second. That equals my velocity at the bottom, which was positive 37 meters per second. I'm in free fall, so I'm accelerating downwards at 9.80 meters per second squared, and I'm doing that for a certain amount of time. Yes. And then I'm going to figure out my time. About what number do I expect? What ballpark do I expect for that time? If it's changing 10 every second and I have to change 37 to 0, about 4 seconds, right? So if I get an answer of 3 billion, have I done something wrong? Probably. If I get an answer of 3.2, probably in the ballpark. I'm probably right. All right? Somewhere around 4. What I'd actually come up with is 3.7 7 seconds. And if I do 2 times delta t, it's actually 2.75 here. 2 times delta t for my time up and my time down, I end up with 7.55 seconds. What did you do? Yeah. Yeah. Do you want to know what you did? You said, I know some other factors, so I'm going to use, and without realizing it, you used this equation. And you said, I know it ends up at this place. It started at 0. It's moving at your third here. And actually what you did, yeah. And so you actually did this, and that's why you had to multiply by 2 without knowing it. Good job. Well, I wish you knew what you had done, but that's why it ended up working out. Okay. So, what is something we know right away about this ball? What's it in? Free fall. So what does that tell us? It's acceleration. Yeah, you guys all, so like, that was great. So number 2, it's in free fall. So acceleration is 9.80 meters per second squared down. Wait a minute. Even though it was thrown downwards, it still has a downwards acceleration? You sure? Even though it was thrown downwards, it still has a downwards acceleration? Yeah. No matter what, it's still. Yeah. No matter if it's a car, a person, a ball, feather, anything, downwards accelerating. All right, let's see. Oh, so we just answered A, didn't we? What's the acceleration of this thing in free fall? 9.80 meters per second squared. Which direction? Down. There's A. A's the answer. It says, what's the acceleration? We know it's in free fall. We know It's accelerating down at 9.80 meters per second squared. Magnitude means how big. And what's the normal way to represent how big something is? Numbers. Numbers. Or don't, it's just big. Yeah. Magnitude means how big something is. It's the speed, it's the shown speed increasing or decreasing. Let's think, it's accelerating downwards. Oh, when I dropped the ball in class, did its speed increase or decrease? When I just dropped the first one, it increased. So what if I had thrown it down, would it still increase? Yes. And the reason it's increasing, remember what acceleration is. Acceleration is the rate the velocity is changing. If it's moving downwards and the acceleration's downwards, that means they're in the same direction, you increase your speed. If they're opposite, it's when you decrease your speed. So since the velocity is downwards, and now I would probably put that right here in my y, since velocity down, coffee man, and accel down, free fall. Sorry, I just got tired of writing free fall. The speed, thanks, increases. Since the acceleration and the velocity are both down, the speed increases. It gets going faster and faster and faster. Yes? So, acceleration is, I know, I have horrible handwriting. I'll work on it. Since velocity and acceleration down, the speed increases. Let's see if there's anything else we need to know. After 0.53 seconds, how far beneath the top of the cliff is the stone? So, let's think about things we know. We know how fast it's going when it starts, right? How fast is the stone moving when the person releases it? Do we know? I heard someone say it. 8 meters per second. Which direction? Downwards. And we know it's accelerating. And we know they want to know where it is after 0.53 seconds. So do we have an equation that talks about where you are? If you start someplace, you're moving and you're accelerating for some time. The first one. Yep. This first one talks about all of those fun things. Which direction? What do you guys want to call down? Positive or negative? Negative. Okay. So, I'm going to end up somewhere below the cliff. What height do you want to call the cliff at? 0. So I'm going to start at 0. I. The I. These are just from the equation sheet in front of you. I just copied the big one. My initial velocity was down, negative, at 8.0 meters per second. You know I'm going to run out of room already, so I'm going to move it over. It's the time I'm moving for, they told me, was 0.53 seconds. Is that right? Yep. Then, I know I'm accelerating down at 9.80 meters per second squared. My time again was 0.53 seconds, and that's squared. Cool, numbers all on one side, D on the other. Don't forget your order of operations, though. Yes. This here, she told me. No, I asked her, I said, what height is the cliff? And she said, I said, what height's the cliff? 0, because I can put 0 wherever I want. So I put it there so I wouldn't have to worry about it. No, in reality, I can set the position 0 wherever I want. So I set it at the top of the cliff. And that's why I was able to put 0 there in my equation. Because remember, D naught stands for where I started. And if I start at the top of the cliff, why not call that point 0?